Today we're diving into something truly spectacular, creating advanced particle explosions in Flutter. These types of effects are perfect for creating highly interactive UIs, such as simulating fireworks, explosions in games, or just adding that wow factor to user actions. Let's kick it off by setting up a new project. First, create a new Flutter app. Once the app is created, open your main.dart file and set up a basic structure of Material app. Now, let's move to creating the particle explosion effect. Add a new Dart file called particleexplosion.dart and start by defining particle explosion widget class. The state class mixes in the single ticker provider state mixin. This mixin provides us with a way to create a single animation controller for our widget. The animation controller controls the duration and progress of our explosion animation. Particles is a list that stores all the individual particles that make up our explosion. Now let's add the logic to animate the particles when a user taps the screen. Inside the initState method, we're creating an animation controller. This controller manages the timing and flow of our animation. We set the duration of the animation to 2 seconds. VSync. This tells the controller to use the current widget as the synchronization source for the animation. This ensures the animation runs smoothly and in sync with the rest of the application. Then we add an add listener to the controller. This listener is like a watchful eye that constantly observes the progress of the animation. Every time the animation progresses, the add listener triggers a setState call. Inside setState, we call the update particles method. This method is where we actually move and update the positions of our particles during the explosion. Finally, we initialize an empty list called particles. This list will eventually hold all the individual particles that make up our explosion. It's like an empty box waiting to be filled with confetti. In the dispose method, we properly dispose of our animation controller to avoid memory leaks. Okay, let's dive into this generate particles method. Imagine you're throwing a handful of confetti. This method is responsible for creating each individual piece of confetti and deciding how it will fly. First, we create a random object. This will help us introduce some randomness and make our explosion look more natural. Next, we create a list of 100 particles. For each particle, we randomly determine its direction and speed. Direction is calculated using random.nextDouble. This gives us a random angle between 0 and 2 pi radians, which covers a full circle. Speed is also calculated using random.nextDouble. This gives us a random speed between 2 and 7 units. Let's talk about this particle class first. Think of this as the blueprint for each individual piece of confetti in our explosion. We have several properties. Position represents the current location of the particle on the screen. It's like the particle's address. Velocity determines how fast and in which direction the particle is moving. It's like the particle's speed and direction. Color property defines the color of the particle. Each particle can have a different color, adding to the visual appeal of the explosion. Size determines the size of the particle. Some particles might be bigger, while others might be smaller, creating a more realistic effect. Lifetime property represents how long the particle will exist before it fades away. It's like the particle's lifespan. Back to the generate particles method. In list.generate, we return a particle object with the position we pass in the parameter, the velocity of the particle based on its direction and speed. Cosine direction and sine direction are used to get the x and y components of the velocity vector. We also randomly assign a color to each particle using colors.primaries. This gives us a vibrant array of colors for our explosion. Finally, we assign a random size and a starting lifetime of 1 to each particle. Once we've created all the particles, we reset our animation controller using controller.reset. This is like rewinding the animation back to the beginning. Finally, we start the animation forward using controller.forward. This tells the controller to begin playing the animation, which will trigger the update particles method to move and fade out our particles. Now let's explore this update particles method. This is where the action happens. This is where our particles actually move and fade away, creating the dynamic explosion effect. Inside method, we start a loop that iterates through each particle in the particles list. Inside for loop, by adding the velocity to the position, we effectively move the particle one step further in its journey. We also reduce the lifetime of each particle by 0.02. This simulates the gradual fading away of the particle. As the lifetime decreases, the particle will become less visible until it eventually disappears. Finally, we remove any particles from the list whose lifetime has reached 0 or below. By removing these particles, we prevent unnecessary calculations and keep our animation efficient. Now let's move on to the build method. We use a gesture detector to detect taps on the screen. We then use a CustomPaint widget to draw the particles on the screen. CustomPaint allows us to draw directly on the canvas. The Particle Painter class is responsible for actually drawing the particles. Okay, let's talk about this Particle Painter class. This class is responsible for actually drawing the particles on the screen. Inside this class, first we define a property called particles. This property holds the list of particles that we want to draw. Then we define the constructor. The paint method is the heart of the Particle Painter. Here we have two parameters. Canvas represents the drawing surface. Size represents the size of the canvas. Inside this method, first we create a paint object. The paint object defines how the particles will be drawn on the canvas. Things like color, stroke width, and blending mode can be configured using the paint object. We then start a loop that iterates through each particle in the list of particles. Inside the for loop, we set the color of the paint object. Particle.color gives us the original color of the particle. With values modifies the color by adjusting its alpha, transparency value. As the lifetime of the particle decreases, its alpha value also decreases, making it appear more and more transparent. This creates the fading effect. Canvas.drawCircle actually draws the particle on the canvas. Particle.position specifies the center point of the circle. Particle.size specifies the radius of the circle. Paint defines the color and other visual properties of the circle. Finally, ShouldRepaint method tells Flutter when to redraw the particles on the screen. In this case, we always return true. This means that the particles will be redrawn every time the animation frame changes, ensuring that the explosion animation is smoothly rendered. And there you have it, a stunning particle explosion effect for your Flutter app. This can be easily customized for fireworks, bursts of light, or interactive effects. If you enjoyed this tutorial, check out other Flutter animation tutorials on my channel. Until next time, keep fluttering.